Okay, good afternoon, everyone. Today, I would like to share our AI projects in live music Taiwan. And our topic is toward intelligent music service. My name is Johnson. I'm the data scientist in Line Taiwan in the data depth team. And I'm in charge of providing data-driven solutions for local projects like Line Fact Checker, Line Music Taiwan, and user tagging and general dictionary services. And this is our agenda today. In these 10 minutes, I will go through how we applied AI technology in live music Taiwan and what we have done to achieve the intelligent results. And the last part will be our future works in summary. So, to simply put, we have these fundamental functions implemented in this service to achieve smart service of music service. The first one is autocomplete, and which is not only the very basic function in a search service, but also what our smart service starts with. So I guess we don't have to mention a lot about what is autocomplete. This is what we always using when typing words in the search bar. The system will autocomplete what you want to type for the rest of your queries with by a ranking of popularity. For this example, if we input prefix of query like alphabets E and A, and based on the over 20 million users query in our music database, the system will probably suggest you with the results of Eagles or Earth Song, as both of them are very popular term in music domain. So for autocomplete, we use a very basic, simple data structure of trie-based tree search algorithm to memorize every word combination based on user search logs from the application. And we have gathered about more than 20 million user search logs and size of 400 million user music data set. And to build, they are to build a module. And we have gathered either of them are names of tracks, singers, or albums. And we insert them to the autocomplete module to build a tree. The tree will then memorize the occurrences of words combination and for ranking more popular terms. And our autocomplete automatic evaluation shows that we had nearly 90% of accuracy of when we have the perfect query prefix from the half length, and also saving users time about 34% input time. That is to say, for an average 10 words query, users have only to input 6.6 words, and the rest of 3.4 words will be complete by our system. And also for a little enhancement for the Chinese autocomplete, we also add a homophonics of query into the tree training so that our autocomplete module could also correct homophonics of different characters into correct characters of query. So, and the second part I would like to share with you is the knowledge results for user query. It's not hard to imagine that if we can understand user query's intention, we can return them with more ideal results. We come up with one of the many ways to achieve so. The method is, could we understand users' intention query with knowledge graph? In live music, there are many ways for the users to come up the query. For what we are most familiar to do is to type the song names or the singer's name of both of them in the search bar at one time. And once our knowledge graph can identify the relationship between the entities in the query, we can give more results users want. For example, here, we queried a famous female singer's song names and her song in the search bar here, and we can see the suggest bar shows her songs in the rank by relevancy. Besides, we provide the users the songs that the query match. The system also suggests songs in the same albums and implies users like the works of other co-creator of the query songs, like the lyric writer's songs and the composer's songs. So they are listed in the suggest bar in the rank of relevancy. And let's see another example here. If we query with two entities, both of them are singers, this is a tricky but not very abnormal situation. Our model can identify that these two entities may be related for some reasons and figure out that they have works in common. So the system will return these common works as results first, and then their respective words in the lower relevance position. So how do we achieve so? To achieve this result we mentioned, we use a star space based solution, which is a word embedding model, and we train on the query query triples, which is like the combinations of entities and relation. So the model can learn the relation between the entities, and like the image above, we have three examples here. Three examples for each example. They are very famous female singer, and the other entity will be their respective songs. And with the relation of singing a song, we can find that the red lines indicate a relation of sing a song. This just shows a similar trait of word analogy to the walkthrough vector. So, and the last one is another scenario you want to apply knowledge to live music Taiwan. And let's see an example in the next page. For users in live music Taiwan, there's a feature to use is viewing introduction of artists' work, and we have observed those data in the database. All of them remains unstructured. That means there's no fixed table recording the entities in this article. And as we observe, and one of the best way to utilize and analyze these unstructured data is name entity recognition. We can recognize custom entities like singer, songs, albums, producers, composers, and so on from those data, and making it to the new relations in the database for further analysis. So in this example, we have extract some other works name and composer's name, and also the producer's name related to these albums that is not existing in the database of our music data. So we basically do the recognition through a framework of fine-tuned BERT model with bidirectional LSTM. And for prediction, we have over 48,000 albums articles. We extract about 55,000 new valid entities from those data. By meaning valid, we invert those entity as existing entity in the database, but not related to the album entity itself. So this is our summary. We have developed a convenient and simple automatic function for search service, and we also, based on this service, we develop more intelligent services like knowledge graph and the name entity recognition. So we have a knowledge graph solution for a more intelligent auto suggest, and then we found a potential way to extract knowledge from unstructured data. As we said, we can implement it non-related or non-relation entities to the original entities in the database. And as for our future works, we definitely want to make this function better, no matter in accuracy or exploring more content from unstructured data like the singer style or the song music style that is not recorded in the database. And there's also a need for us to refine the current models with users' evaluations and reduce model size for reduce model complexity for online efficiency if we want to make it to a real production environment. And that's all my sharing. Thank you very much.